So last time around we implemented a very simple template caching system, and what we did was to create a package level variable named tc for template cache here in the file render.go, and then we modified our render template function to check and see if we had the template we want to render in that particular variable tc, our cache. If it doesn't, we create that template, we add it to the template cache and move on. If we do have it in the template cache, we use that instead. And that works really well. And as I said last time around, this may be exactly the kind of template caching system you're looking for. But as I also said last time around, the only thing I don't like about this is that I have to remember to come down here to the create template cache function and add anything that needs to be available for a given template to this slice of strings. I find that awkward. So what I'm going to do, and you might want to save your code, but what I'm going to do is to delete all of this, everything we did last time. So I'll delete all of that. And then I'll rename this one to render template. Okay? So we're back where we were 2 or 3 lectures ago. And that's not really a problem, because what we're going to do this time around is a slightly more complex method of looking at the templates and the partials and the layouts and so on and so forth on the file system, and have them automatically populate a template cache. And it's not that difficult. It might seem a little bit complex, but we'll go through it slowly. Okay? So the first thing I want to do here in this function render template in the file render.go is to save to get rid of this use of log. So that gets rid of my error. The first thing I want to do right here, and we'll write some comments and then we'll worry about the rest of it later on. Okay? So the first thing I want to do is to create a template cache. Okay? And then I'm going to want to get the template, get requested template from cache. Okay? And then I'm going to want to render the template. Try that again. Render the template. So at a very high level, this is very simple. This is not much different than what we're doing here, except line 17 is going to change. So the first thing I'll do is worry about creating a template cache. So I'm going to come down here and create a new function, and I'll call this one, same as last time, create template cache. And it's going to take no arguments, but it's going to return a map of string, and no surprises here, pointer to template.template. Okay? And it also might return an error. So let's put that in there as well. Error. And I think I have... yeah, I got an extra parentheses there somehow. Okay. So this is the function that has caused people the most grief over time. And that's simply because the first time I recorded this lecture, I just went through it too quickly. So I'm going to make it a little simpler this time. Now, we're going to be returning a map of string pointer to template.template. So we'll create that variable. Now we can do it like this. I'll just call it my cache. Is assign the value of make map string pointer to template.template. And that's fine. That's how we looked at creating maps the last time around. It's how we did it much earlier in the course. But there is another way of doing it, and you may as well become familiar with it. So rather than doing this, which I'll comment out, you can also create a map this way. You can say my cache, which is just a variable name I'm choosing right now. That's assigned the value of map string pointer to template.template, and then just use curly brackets and make it an empty map. That's exactly the same functionality as using the make keyword as we did here. Okay, so I'll get rid of that. We'll leave it this way. You may as well get used to that syntax because you'll see it in other people's source code if you start returning other projects. Now, what do I want to do in this? I need to create my template cache, but I want to create my entire cache at once and populate that map with every available template and every available partial and every available layout, everything that's in the file system. And it's all going to be in that root or that folder at the root level of my project called templates. Now, one thing to bear in mind, when you're rendering a template that uses a layout, you typically must have, as the first thing you try to parse, the template you want to render, and then the associated layout and partials and so forth after the fact. That means when I start parsing my templates and adding them to my cache, I want to do everything that ends in .page.tmpl first. And that means I need to somehow go to the file system, look at the templates folder, and get everything that ends with page.tmpl from that folder into a data structure I can loop through. And fortunately, Go makes that really easy. So what I'm going to do first of all is get all of the files named star.page.tmpl from the .templates folder. Okay? So we can do that by saying pages, which is just a variable name I'm choosing right now, and error are populated when I call, right from the standard library, file path is the package .glob. Okay? And it's an unusual name, but as you can see right here, glob returns the names of all the files matching the pattern, or nil if there is no matching file. The syntax of the patterns is the same as in match, which we don't care about. All this says is go to some location and look for these files. And I want to go to the root level of my application, /templates, and then my pattern is just star.page.tmpl. And that populates pages with, as you can see here if you point at glob, a slice of strings, okay? So we'll have to check for an error in case that templates folder doesn't exist, for example. So we'll say if error is not equal to nil, then we'll return my cache and the error, okay? But if we get past that, we now have a slice of string with all the files that end in .page.tmpl from the templates folder. And what we're going to do next is range through the pages. Range through all files ending with star.page.tmpl. That's it, okay? And that's just a for loop. For, and I don't care about the index, so I'll use the blank identifier. And I'll look at each iteration. I'll look at the values stored in page. Those are populated when I range through, not rage, but range through pages. Okay? So we now have a for loop, and every time we go through, we're going to have this value page populated with whatever we get from the slice of strings. So the first thing I'll do is get the actual file name. Now, if I was to print out the value of page in this loop, you would see that it's the full path to the name of the template. And that's not what I want. I want just the name of the template. And fortunately, we can get that. We'll store it in a value called name, which is the file name. We can get that by using the file path package again. File path dot, and we're looking for the function named base. And we hand that page. And if you look at base, it tells you exactly what it does. It returns the last element of the path. And in our case, that will be the name of a file that ends in page.tmpl. So that's what's currently stored in name. Okay, so we have that. Next, what I want to do is to try to parse that file. Okay, so we'll say ts and error. Ts just stands for template set. So ts and error is just an error. Those are populated, same as we did before, by going to the template package, template dot, and this time I'm going to give the template a name, okay? We're going to call new, which is different than we did before, but it's no big deal. We're going to call the name of this template name, that value we got on line 37. So the first time through, if we're looking at, for example, home.page.tmpl, then name is set to home.page.tmpl. And we're going to parse files. And we'll hand it page. Okay? So at this point in the for loop, the very first thing I did was get the name of the file I'm currently looking at, minus the full path to it. So just something like about.page.tmpl. Then on line 38, I populate a variable called ts for template set while checking for an error when I parse the file named page and store that in a template called name right here. Okay, so that's all that this line is doing. And once again, we'll check for an error. So I can just copy this and paste it right here. If error is not equal to nil, something went wrong, so return the error and whatever the current value of my cache is. It might be an empty map, it might have a value or two in it, but all we'll care about is the error, so it makes no difference. Okay, So once we get past that, we now need to look for any layouts that exist in that directory. And we can use the same syntax we did when we looked for pages. So we'll say matches, which is just a variable name I'm picking right now, and error are populated when I call filepath.glob. But this time I'm looking for the layouts. So /templates/ anything that begins with any value but ends with layout.tmpl. Okay? That will give me a slice of strings with all the layouts. And in our current situation, it'll be a slice with one element in it, but that's okay. That's all we really care about. And again, I can paste in my error check right here. So I haven't done anything with TS, and I haven't done anything with matches, but we're getting closer here, okay? So we'll say here, after we've checked for matches, we'll say if the length of matches, and that's the built-in function len, and all that does is tell me how many elements are in matches. So in our case, there will be 1. So if that is greater than 0, then I have to deal with the templates. So now we take that variable ts, and we check for an error again, and I can use the equal sign because I've already set ts and I've already set error. Now I'm going to say ts.parseGlob, okay? And we'll look at that in a minute, but first of all, let's finish writing this particular command. Inside the parentheses, in double quotes, I put /templates/star.layout.tmpl, okay? And I'll paste in my error check, which hasn't changed at all. So in this case, what does parseGlob do? Well, it says right here in the comment, parseGlob parses the template definition in the files identified by the pattern and associates the resulting templates with T, okay? Now, T in our case is TS, but all this is doing is saying, well, some of these files up here, the ones that end in .page.tmpl, they might require these files down here. So parse those and add them to the template set, okay? And then after we've finished all of this, down here, still inside the for loop, all I have to do now is say my cache, that map we created right at the beginning of this lecture, at the key, and the key will be name, so it'll be something like home.page.tmpl or about.page.tmpl. That's equal to the template set, okay? The current template set. So this, the first time through, we'll deal with, say, for example, about.page.gohtml. Then it will realize that there's a layout, so it adds that to the template set. And finally, it adds everything together with this parseGlob function. And then it adds the final resulting template to my map. That's it. And then down here, the last thing I have to do in this function is to return my cache and nil, because we have no error, okay? So we have this function, create template cache, but we're not using it, which means we need to come back up here, and we're going to, as the comment says, the very first thing I'll do is create my template cache. And I do that by saying, I'll call mine TC for template cache. You can call yours whatever you want. And error are populated when I call create template cache. And that requires no parameters. If there's an error, if error is not equal to nil, then I want to die at this point because the application can't start if its pages aren't available. So I can die by saying log.fatal right from the standard library and just print out the error. And that will tell me what went wrong. So at this point, I have my template cache, okay? So now I want to actually get my template to render. Now, if you recall, here on line 12, the function render template takes a response writer. That's what we're going to write to. And then it takes the name of the template I want to render. And that name of the template will be, in our case, either home.page.tmpl or about.page.tmpl. And I know if I get past line 14 and the error check, I know that I have my template cache and it should have 2 values in it. One for the home page and one for the about page. So I can get my template from the cache by saying, and I'll just use T for template, and OK. They're populated when I get from my template cache the map I got on line 14, looking for the index TMPL, the parameter I got from this function. And remember, this syntax is exactly what we used in the last lecture. T, in this point, will hopefully be the value of the template that I want to render, and OK will be true if it is, or it will be false if it couldn't find that. So all I have to do, once again, is a simple check. If OK, sorry, try that again, if not OK, then I can't get that template from the cache. So I'll say log.fatal error. Okay? If I can't find the template, I'm just going to die, which isn't very polite, but we'll make this better as time goes on. Now this next step is completely arbitrary. It's an arbitrary choice on my part, okay? And it's kind of a belt and suspenders sort of thing. You don't have to do this, but I'm going to. I'm going to create something called a buffer. That's my variable name. And it's nothing more than a new, which is a keyword built right into Go, and it's of the type bytes.buffer. And this is just something that will hold bytes. What I'm going to do is try to execute the value that I got from that map. But rather than doing it directly, and you can do it directly if you want to, I'm going to try to execute that buffer directly and then write it out. And the only reason I'm doing this is for finer grained error checking. Because once I have declared this buffer, I can ignore the result, because I don't care about that, but call t.execute. T being the template I got on line 21 here from the map. I'm going to execute buff and nil. And this gives me a clear indication that the value I got from that map, there's something wrong with it. It parsed it, but I can't execute it. And I don't know what situation that might be, but sometimes it's like black magic working with code. And if I can figure out exactly where the error is coming from, as closely as possible to the offending line in my code, then I usually take that step. You don't have to do that. It's entirely up to you. But now I can say, because t.execute gives back an error, I can make this equal to error, which I should have done when I typed it. And I can say if error is not equal to nil, then log.println the error. And that tells me that the error comes from the value that's stored in the map. And that's the only reason I'm doing that, okay? And that finally means I need to make a slight change to the way that I actually render the template, okay? It can't be like I've done it here. In fact, I can delete this entirely. Instead, I can say, ignoring the first return value, but checking for an error, when I call buff, that variable I declared on line 26, dot write to, right there, a built-in method that's available to that type, I'm going to write to my response writer. Okay, and now I can check for an error. If error is not equal to nil, then I can log.println the error. Okay? And that's all I need to do at this point. Now, this is not a lot of code. We go from line 41 here to line, if I delete this blank line, 74 here. So that's not very many lines. And up here, my render template is now probably twice as long as it was before. But the advantage here is that I no longer have to keep track of how many files are in my template folder and how many are using a particular extension, .page.tmpl or .layout.tmpl. All of this will happen magically. I just need to save here to get rid of the format import, okay? So when this function is called, the very first thing it will do is create a template cache. Now right now, it's going to create that template cache on every request, but we'll change that before too long, so don't worry about it. We're just getting started here, okay? This will create the template cache, and this is where the magic happens. So the first thing we do is declare a variable of type map string, and that map holds pointers to template, something that I can actually render, something that's already been parsed. Then I get all of the pages right here, find all the files named or with the extension .page.tmpl inside the templates folder at the root level of my directory. So I have that in a slice. Then I arrange through the slice. The first thing I do is take the value that I get in page, which is the full path name to my template file, the one that ends in .page.tmpl, and I call file path base to strip off the path to it and just leave the last argument in that, which is the name of the file itself. Then I create this variable, which is a pointer to template.template. I give that template a name and I parse the file page, okay? And then I look for layout files. And if I can find a layout file, I deal with that layout file and I parse it. Okay? So finally, at this point, I can add to my template cache at the key name, which in our case will be either page or home.page.tmpl or about.page.tmpl. I add my template set to that. And when I'm done looping through everything, I return my finished map. Let's try this out and see if it works. So I'll open my terminal. I will quit the application and clear the screen and type go run./cmd/web. Okay, so it started up. Let's go to our web browser. Let's reload this page. And there's the home page. Okay? And that works exactly as it should. Now at the moment, this isn't finished. We still have some work to do on this. But at the moment, right now, every time I render a page, any page on the site, I'm creating that template cache right from scratch on every single request. And obviously, all we've done so far, if we leave it like this, is make things more complex and harder to read. We haven't made it any faster at all. We're still reading all the required files from the disk, parsing them, putting them in a map, pulling the value out of the map, and then rendering it. But this is a good start. It is getting us in the right direction. And I no longer need to keep track of what files are inside of my templates folder. Okay? So let's move on and see if we can improve on this even more. And we're going to do that, to start with, by working on an application configuration. So we'll get started on that and a few other things in the next lecture.